Hi, welcome back, and I'm going to be continuing off where I left off before, which was the lesson 1.1. So now I'm just going to be doing the questions from the chapter 1.1 review, just a few questions. So let's take question 1, for example. Okay. A cardinal flies east for 2.9 seconds in a horizontal plane for a distance of 22 meters from a fence post to a bush. It then flies north another 11 meters to a bird feeder for 1.5 seconds. Calculate it. So it moves 22 meters east, or 22 meters, yeah, in the horizontal distance, in the horizontal plane to the east, and it moves to 11 meters north. So your total distance would be 22 meters plus 11 meters, which is 33 meters. Your total time it takes is 2.9 seconds for 22 meters, and then takes 1.5 seconds for 11 meters. So your total time total is 2.9 plus 1.5, which is 4.4 seconds. So your speed, you can calculate speed. So yeah, you can calculate speed, but the question is just asking you for the distance traveled. So the 33 meters is the total distance traveled. For part B, it's asking for speed. Since you know the time, you can just find speed, the average speed, which is distance over time, which is 33 meters over 4.4 seconds, which gives you 7.5 meters per second. Now for part C, it's asking you to find the cardinal's average velocity. Now for velocity, it gets a little bit more difficult because now you have to incorporate directions. Before you could just add the distances because there's no direction, but now you have to actually incorporate directions. So I'll draw a diagram for this one. So 22 meters north, 22 meters east, sorry about that, and then it goes 11 meters north. So your displacement, your total displacement would be this. So how do you find displacement when it's a triangle or on a diagonal, when there's east and north, when there's components of y and x, or y and x? So how would you find the displacement? Well, you know this is a triangle, so you could just use the Pythagorean theorem to find the hypotenuse, which is the displacement, total displacement. So dt squared equals 22 squared plus 11 squared dt equals square root of 22 squared is 44, and 11 squared is 121, and then you're left with root 605. So root 605 is your displacement, but since the displacement is on an angle, you would have to find the angle. So to do that, you could you would have to find the angle here, theta. Let's say theta is the angle you're trying to find. So how would you find theta? Well, you know this, the opposite, you know the adjacent, so you could just use tan theta, right here. Tan theta equals 11 over 22, because opposite over adjacent, and then you could just do the inverse of tan, and you end up getting 26.6 degrees. So your total displacement is root 605 meters east, 26.6 degrees north. It's asking for average velocity, but you have the total displacement. So what you could do now, since you have the total time too, you could just find velocity by doing average. You could find velocity by doing displacement over time, which you know the displacement is root 605. So root 605 is 24.6 meters at east, 27 degrees north. I rounded the angle to 27 degrees north. I know the time is 4.4 seconds. So divided by 4, and you end up getting 5.6 meters per second east, 27 degrees north. So that would be your average speed. Let's go on to question number 2. So you're told to find the average speed in terms of meters per second. You know the average speed is 15.0 kilometers per hour. So to convert that to meters per second, kilometers per hour. So in 1 kilometer there's 1,000 meters times 6 times 60 minutes in 1 hour, and 60 seconds in 1 minute. So the kilometers and kilometers cancel, the hours and hours they cancel, the minutes and minutes they cancel, so you're just left with meters and seconds. That's exactly what we want. So 15 times 1,000 divided by 60 times 60, which is 3600. So that is 4.17 meters per second. Now question part B is asking, calculate the time in seconds needed to complete the lap. So you know that the speed in meters per second is 4.17 meters per second, and you know the total distance for 1 lap is 2.9 kilometers. So velocity, not velocity, the speed is 4.17 meters per second. So you can just rearrange the speed formula to get your time. So 2.9 kilometers is 2,900 meters. You can just do 2.9 to the exponent 3, 2,900 meters over 4.17 meters per second. The meters and meters cancel. 4.17. You end up getting 695 seconds. Let's try two or three more questions. So let's try question number 4. Airplane An airplane flies 450 kilometers at a compass heading of 85 degrees for 45 minutes. Calculate the airplane's average speed. Part A, and then part B, calculate the airplane's average velocity. So, since you know the entire distance, you can calculate the speed easily by doing average speed is change in distance over change in time. First, you should convert 45 minutes to seconds equals, gives you 2,700 seconds. So, and then 450 kilometers is 450,000 meters, because you just times it by 1,000. 2700, cancel the zeros, 700. And your average speed for the plane is 167 meters per second. Now if you want to find that average velocity, it's going to be the same thing, but now there's a direction, a compass heading of 85 degrees. The compass heading is 85 degrees, so I'm just going to draw a diagram. So this is north, south, east, west. The compass direction is 85 degrees. So let's say this is 85 degrees. Not to scale, but let's just say this is 85 degrees. So that means this angle here is going to be 15 degrees. So you could say that the velocity, since the displacement in this case is actually the same as the distance traveled, because it was originally at 0 meters and then it traveled 450,000 meters, your displacement is going to be 450,000 meters at this angle. So 450,000 meters east, 15 degrees north, because it goes 15 degrees and takes a north. So it goes like this, 15, and it goes east and then takes a 15 degree north. So that's why you write east, 15 degrees north. That's the direction over 2,700 seconds, and you end up getting 167 meters per second east, 15 degrees north. Let's look at question number 6. I'm going to do 2 more questions, 2 or 3 more. So, question number 6. The average acceleration is 1.37 times 10 to the power 3 meters per second squared. And the time it takes is 3.12 times 10 to the power -2 seconds. So it's telling you to find the velocity. So you can just rearrange the formula. It's very simple. Change in velocity over time. Velocity equals average acceleration times time. And so 1.37 times 10 to the power 3 meters per second squared times 3.12 times 10 to the power -2 seconds. Second and second squared cancel, so just seconds left, so meters per second is just left over. And if you do that, so 0.37 exponent 3 times 3.12 exponent -2, you end up getting 43 meters per second as the velocity. Very simple. Let's take some practice. I'm going to try some of the graph problems. So for question 8, the position time graph in figure 13 represents the motion of a race car moving along a straight road. determine the average velocity for the entire trip. So the entire time for the car is 14 seconds and travels 400 meters in that time. So the velocity would be, the average velocity would be 400 meters east, which is the displacement, over 14 seconds. If you do that, you should get 28.57, or I'm just going to round to 28.6 meters per second east. I'm not doing any significant digits here, but if you do significant digits, then your answers might round, so maybe your answers might not be the same as mine because your teacher might want significant digits. I'm not doing significant digits here, but if your teacher wants it, then just round your answers to significant digits, to the lowest significant digits. So 28.6 meters per second east is the average velocity. And now part B is asking, determine the average velocity for the last 10 seconds of the motion. Why are the two average velocities different? So for this question, for the last 10 seconds of the motion, so 14 seconds is the last point, so the last 10 seconds would be from 4 seconds to 14 seconds. So at 4 seconds, it's roughly 25 meters, I would say. So velocity average equals change in displacement over change in time. Time is 14 minus 4 seconds, which is 10 seconds, and your displacement. I know before I said this was 400 meters, but like if you look closely, it's a little bit above 400. So back of the textbook, the answer for this is 29 for part A, so it's pretty close. But like for this question, I'm gonna say that displacement is actually like 410. So you could say it changes to like 410 or something, and your answer might be more closer to the answer of the textbook, but I'm not gonna like rewrite that. So here it would be 400, let's say 410, and then here it would be like 25-ish. So 410 minus 25, 410 minus 25, 385, and then that over 10, so 38.5, or 39 meters per second east is the velocity for the last 10 seconds. So why are the two velocities different? Well, they have to be different because the position at the time you're doing it at is gonna change. So like here, it's if you do a secant line, let's say you do a secant line, it would just be like that, something like that. But if you do it from 4, you can see that the secant line from 4 seconds to 14 seconds is actually more steeper. It's actually more steeper, and since it's more steeper, that's why the velocity is greater, because the velocity is basically the slope, remember? Because if you think of it, slope is the y2 minus y1 divided by x2 minus x1. So you can think of this as y2 minus y1, and this is x2 minus x1, or yeah, y2 minus y1 divided by x2 minus x1, which is slope. So you can think of it as slope, and since it's more steeper, that means it's going to have a greater slope, which is why the velocity here is greater than the velocity over there. So for part C, it's a little bit more difficult because it's kind of hard to draw it on these things, on these books. It's hard to get very accurate drawing a tangent line. So for instantaneous velocity, you have to draw a tangent line. So I'm just going to do 4 seconds. I'm not going to write it on the book, but it can be kind of difficult to do at times. So I'm just going to do it here anyways. So at 4 seconds, So at 4 seconds, if you were to imagine there's a tangent line here, it's very difficult to find the points, but I would say at 4.5-ish, 4.5-ish. So velocity average, velocity instantaneous actually is maybe 4.5 seconds minus 4 seconds, and at 4.5 I would say it's roughly 20, not 25, it has to be greater than 25, maybe 35. It's very hard to tell from this diagram, but you just have to like give your best guess in these situations. So 35, 25. So that's 10 meters. So the answer I got was 20 meters per second, and at the back of the textbook it's 17 meters per second. It's pretty close. It's kind of hard to tell in these kind of diagrams, so you gotta give it your best guess. But yeah, it's close to 20 meters per second. The back of the textbook is 17 meters per second, which is the exact answer, but if you get something close to this, it should be, your teacher should accept it. So yeah, you can try the rest of the questions. They're almost basically the same, they're basically the same concepts, so you guys can give it a try, and I hope this video helped. I'll be posting more videos soon about more questions. Next chapter is equations of motion, which are like the 5 fundamental kinematic equations. So yeah, I'll be doing that as the next video. So I hope this helped you guys, and if it did, give it a like, and yeah, I'll see you guys in the next videos.